Hi, so in this video I'd like to talk about type hinting. As we all well know, Python uses dynamic typing or duck typing. This means that unlike other statically typed languages like Java, variables in Python do not have a static type. They are simply labels that reference objects. Those objects definitely have a specific type, but the label is nothing more than a pointer to some object. Over time, though, people have found a need to still assign a type to variables, especially to function arguments and return types, but other things as well, like just plain variables in a class or variables in a module. So type hints happened, and we'll come back and look at why we wanted type hints. So first, we saw some external libraries, some third-party libraries, like for example the static type checker called MyPy, that started doing type hinting. And then a lot of those ideas from MyPy were actually brought into the canonical Python itself and integrated directly into Python. Now the thing is with type hints that they in no way modify how Python itself runs. The type hints do get compiled along with the rest of your code, but they do not affect how Python executes your code. Let's take a look at a simple example of assigning type hints to a function's arguments, and we'll leave out the return type hinting. We'll just do the function arguments. So let's go ahead and say we have a, that is an int, and b, and that's a colon, int, and then b with an int. So this function here takes two arguments, a and b. That's what Python sees when it's going to run the code. It's going to say, hey, I'm expecting the two variables a and b. No different than if we had not put in the type hints. In addition, though, we've specified here two type hints. A should be an integer, b should be an integer, and then this function is going to return, let's say, a times b, like so. So, according to the type hints, when we call mult, we really should be passing in integers, and that works just fine. However, what happens if I try and pass in, let's say, a string and an integer? We know that strings and integers can be multiplied with each other. But according to the type hinting, we're saying, no, a should be an integer, yet I'm passing a string. What happens? Absolutely nothing. The code runs just fine. That's what I mean, that Python compiles this, this type hint. You cannot just specify whatever you want here. It has to be a valid data type. In this case, Python comes back, it does try to compile your hint, and it says, well, I don't know what text is. So here, I'm going to go back to int. But when it comes to actually running the code, what you pass in as the argument type doesn't matter. This is not static typing. This is why it's called a type hint. So then the question becomes, well, why use type hinting at all? And there's actually a number of good reasons to use type hints, even if Python basically ignores them. One of the things is that it helps IDEs display context-sensitive help information, such as not only the function parameters, but also what the expected type is. The other thing that type hints are very often used for is for documenting your code. And in fact, you have several automated document generators that are able to use those type hints when they generate documentation about your code. Maybe you're writing a code library with lots of functions and classes, and you include comments, document comments for your functions and so on. And then you use something like maybe Sphinx, for example, and it can actually use the type hinting to add that to the documentation. Very useful for documenting code. And then you have other libraries too that can actually leverage type hinting as well. For example, you have in Python's own standard library, you have these things called data classes. Data classes are actually nothing more than code generators. A data class is a code generator. It's not a new construct in Python. It's not a new data structure. It's not a new type of thing. It's a code generator. How does it generate the class code? Instead of you writing, at property, def, this, and so on, instead of doing all that manually, you can use a more declarative approach, and you use type hinting. So these modules can leverage type hinting to do something else. Even though Python itself doesn't use the type hinting, because it is compiled, that information is available with introspection. So something like a data class can then use those type hints to do something with them. You also have third-party libraries like, for example, Pydantic that uses it for runtime validation, for example, as well as other things like serializing and deserializing your data. And I actually will create a video on Pydantic. It's a very, very useful library. And in fact, it's also foundational to the Fast API library that has become very, very popular for asynchronous REST API development. And they really leverage Pydantic for that. So I'll do a video on Pydantic later. So let's look at how we can specify some type hints. We've already seen how to do some simple stuff here. And with this video, I'll stick to relatively simple cases because it can get pretty complicated. And as hinting continues to evolve, it's, more and more is going to become possible as well. So for standard types, hinting is very easy. We saw that example. Let's take a look at another one. Let's say we do this def func, and we're going to say a dict. So we're going to say that a, we're going to type hint as a dictionary. B, we're going to type hint as a list. And C, we're going to type hint as a Boolean. And we can even, if we want to, add a default value. Nothing wrong with that. That's the syntax. You first specify the hint and then your default. Okay, so that's a way that we can add more information about what A, B, and C are. Now note that we didn't really define what this dictionary structure should look like or what the list should look like. Is this a list of integers, a list of floats, a list of strings? We can do that with type hinting, and we'll come to that in a bit. You can also use type hinting with keyword-only arguments, nothing changes. And if you're dealing with more modern, with the latest versions of Python, you can also do that for positional-only arguments, nothing changes. It's just the same thing. You have the variable name, colon, and then the type hint. The variable name, colon, so these are keyword-only arguments. And then you can also, even if you want, specify a default for any of those. Now we can also specify the return type hint for a function. So for example, we could say this, we could say func, and I'm just going to take this. Well, actually, let's go ahead and write a new one. Let's say that we have A is an int, B should be an int, right? So we're not saying that it will have to be an integer. That's just a hint, right? We're just saying to somebody looking at your code or looking at documentation generated from this that A and B should be integers. If you want to pass in a string, well, try and see if it works, but that's not guaranteed to work. And here we can specify the return type. We can say this function, given these two inputs, A and B, that should be integers, will return a string. And we just use that kind of arrow style notation to indicate the return type. And so this could return something like an F string, maybe we'll say A equals and then B equals, like so. And I'm not going to bother running these functions because it doesn't affect, as we saw, how Python runs. It's just type hinting. Now, a function doesn't have to return a value, but of course, when we don't return a value, just keep in mind that the function still returns something, right? Every function in Python, when it gets called, will return something. If you don't have an explicit return, it will just return none. So if you got a function that doesn't return anything or that returns none explicitly, then you could notate it this way. You can say it returns none, like so. And then I'll just pass. So where things get more interesting is when we're dealing with more complex types, or maybe when we're willing to accept different types for the same argument. So let's start with that. Let's start with type hinting a function that can accept either an int or a float for some parameter. So to do this, we're going to need to use the typing module. So from typing, we're going to import something called union. So the union in here is going to allow us to specify multiple types for a single argument. Let's go ahead and do that. So let's say that A can be either a string or an integer. Well, we would write it this way: union string, comma, int. And then B, let's say, well, that should be an integer. And this function is going to return, and we're going to return A times B. So what is this function going to return? Well, if A is a string and B is an int, it's going to return a string. If A is an int and B is an int, it's going to return an int. So again, it's going to return the union of string and int, either a string or an int, like so. And then we can just return A times B. Now, in more recent versions of Python, this is Python 3.10 and above, there's actually an operator that's built in that you can now use instead of using union. If you remember the set operators, the pipe character was a way of defining the union of two sets, right? If we say 1, 2, union 2, 3, then we get the set 1, 2, 3. That was the union. Well, guess what? We can use this now instead of using union from typing. So if you're dealing with 310 and above, you can just say A can be a string or an int, B needs to be an int, and then the return type will be a string or an int, like so, and then we'll return A times B. So you can use that with 310 and above. If you need to be backward compatible or you're not working in 310, then you're going to have to use union from typing. There is also in typing a special type. So from typing, import any. And any just basically says it can be anything. So you could say this. You could say def format A is really anything. And then it will, basically have none for its return. And here we'll print the string of A. It might be a function that's like that. It doesn't return anything, and A can be anything because any object in Python, any type, has a string representation of some sorts. Now we can also indicate that an argument can be none by using the optional annotation. Now that is not the same thing as an optional parameter. This is more for specifying that an argument is required, so it doesn't have a default, it's not an optional parameter, but it could either be a specific type or it could be none. We could say we're going to accept none as an actual argument being passed when this function gets called. So let's take a look at that. We can say from typing import optional, and then we can say def func, and then we'll say A needs to be provided. It doesn't have a default. This is not an optional argument, but it will take either an int or let's say it will take none, right? So this is one way of writing this, and let's say it doesn't return anything, so we'll do that. So you'll notice here what's going on, right? We're saying A can be an integer value or it can be none, but it's still a required argument. You cannot call func without passing anything. That's not going to work, right? But you can pass it none. That's perfectly fine. You've passed an argument. So this is a type hint to indicate that. So you can write it this way, or you can also write it this way. You can say A is the union of int or none. That's another way of writing it. You could do this like so. And then the other way is to say def func, and this is probably the preferable way of doing it. You can say it's an optional int. That basically kind of says it's an int or it could be none. But that's not saying that A is itself an optional argument. It's not. It's a required argument as far as Python is concerned. So far, we've been using quite simple types, right? We've used ints and strings and floats, things like that. And we started, peppering in union and optional and any, those kinds of things. But we can also annotate container types, such as lists or tuples and dictionaries and so on. So we saw that we can indicate, that an argument is going to be a list. For example, def func L should be a list. We can annotate it this way. That is fine. That's acceptable. But this is kind of a little too generic. It's saying, well, it's a list. But a list of what? Sometimes your list needs to be a list of a specific type or a specific, possible types. Maybe it's a list of integers or floats, or a list of, it should be a list of strings, right? So you'd want to be able to annotate that somehow. And this is where we need to use something called generic types, or simply generics as they're often called. So we're going to get those from the typing module. Now, I've told you that type hinting is evolving. So right now, all these things work with the typing module, but some of these generics are starting to move to other modules in Python. And later on, I'll give you a little bit more detail about it at the end, and I'll give you a link to the Python docs that will explain which ones are moving. So they're getting deprecated. I think started in Python 3.9. A lot of them got deprecated. So they're still available in the typing module. If you're working with prior to 3.9, you have to use them from the typing module. 3.9 forward, you don't have to unless you want to remain backward compatible. So we'll come back to those. I'll have a link to it. The Jupyter Notebook, by the way, it's in the GitHub repo. I'll have the link below the video to where it is in the GitHub repo. Okay, so let's go ahead and do that for the list first. So from typing, we're going to import list. So this is a generic type, this list. And what the generic type allows us to do is to specify what the type is. And we do that by taking the generic type and using the square brackets, not round brackets. We're not calling this. It's a little bit different. We're specifying the type. So here we could say, well, we want a list of integers, like so. And if I run this, you can see Python compiled it, and we get this object, typing list int, right? And so we can use that as we're annotating arguments of a function, for example. We could say L needs to be a list of, let's say, floats. And it's going to return, this function is going to return a list of integers. So we're specifying that, and for something like this, we may write this kind of code. We may say, well, take the integer value of every element for EL in L, like so. So as you can see, it's expecting a float, which means we can take the int of the float, it's going to truncate, and then we're going to return a list that's going to contain integers. And that's what our type hint is over here. Again, just to reiterate, Python will gladly accept a list of integers here if you want to call func of a list of integers. You could even pass it a list of strings if you wanted to. Python's not going to complain about you passing it a list of strings. It's going to complain here potentially, right, if it cannot transform that string to an integer. The type hint doesn't change how Python runs. It's just a type hint. Now, there are plenty of generics available in the typing module, so you should read up about them in the Python docs. And as I'll mention later, some of these are generics in the typing some of these generics in the typing module are being deprecated. For now, we're just going to keep the typing module. So sometimes we want to indicate that a sequence of objects can be a list or a tuple, and we can do that. We have list. If you look at the typing module, you also have tuple, so you could do that. But you can also say, well, I just want a generic sequence type. So I don't care if it's a list or a tuple or maybe a custom sequence type that you implemented with your own class. And so for that, we have another generic from typing called sequence. So from typing, import sequence. And as you may probably guess, it works the same way in terms of specifying what can be inside the sequence. For example, we could say def square. And then we have, let's say, numbers. That's a mandatory positional argument. And we're going to type hint it and say this is a sequence. And the sequence can be float or int. And I'm going to use the Python 3.10 notation here. But if you don't want to do that because you're on an earlier version, then you could do it this way. So this function is going to accept any kind of sequence type of floats or integers, or at least it will accept anything, but that's what it should be. And given that, it's going to return a list of, let's say, float or integer. So I could write it float or int. And if we don't want to use this operator, you can just use the union. Just say union float int, like so. Okay, you could do it this way as well. And this maybe is going to return EL times EL for EL in numbers, like so. Now, in cases where we may be reusing the same type annotation over and over again, maybe you're building a module of functions that mostly take, sequences of floats or integers, as we saw in this square function. Well, every time you have that, you're going to have to repeat, this whole thing over here. Or maybe your return type is the same for many, many, many functions. It gets tedious to rewrite this over and over again. So what we can do, we can actually just assign it to a symbol. So we can just say, let's say the symbol vector is the sequence, because as you saw, it just gets compiled, right, as an object. So let's say this is a sequence of float or int, like so. So if we look at vector, you'll see it's just this typing.sequence float or int. And by the way, if I change this to be union float comma int, like so, then you can see that our result is actually the same thing. It's equivalent, right? So now that we've got this vector, instead of reusing this and retyping this all the time, we could say something like this. Let's say we want to calculate the norm of the vector. So we'll say v, and we'll just say v should be a vector, like so. And then that's going to return, let's say, a float. And I'll just pass. I'm not going to implement the Euclidean norm here. So now let's switch to specifying hints for dictionaries that are a little bit more specific than just using the dict that we saw earlier. And for that, again, we have a dictionary generic in the typing module. So from typing, import dict, like so. And so now with dict, we can specify hints for both the keys and the values. So for example, I might say dict string, comma, int, like so. And this basically is saying that this is a dictionary whose keys should be strings and whose values should be integers. And of course, we can combine this now with everything else we've seen. So for example, we could say, I want a dictionary whose keys are strings, but whose values can be either an integer or a sequence of integers, like so. And I'm going to spell it right. And you can see, by the way, how it transformed that pipe operator into union, right? We could have used union as well. But this basically is saying that this dictionary has string keys, and then the values are either integers or a sequence of integers. And you can take a look at the Python docs. There's lots of generics for lots of different, kind of standard types. But one more that I'd like to cover is basically how to specify type hints when a parameter to a function is a callable. Or if you have, let's say, a class variable or a variable somewhere that's a function and you want to give it a type hint. Here I'm just really showing where it's used most often, which is inside functions and for type hinting function arguments. So let's take a look at the map function. You know the map function in Python. Basically, you can call the map function, you pass it a function and you pass it an iterable, and it will apply that map to that iterable. So let's go ahead and do something similar. We're going to write our own custom one. We don't need to because it's built in, but I want to show how we might annotate a function like this. So this function here takes in two arguments, func and sequence, and then we're going to say for el in sequence, and we're just going to yield the string value of func applied to el. So we're going to call func with every element of the sequence one at a time. As we iterate through it, we're going to transform that response to a string, and then we're going to yield it. So it's a little bit different than the map function. The map doesn't convert to a string, right? In this case, a little bit different, and it's just so that we can play around with some of the type hinting. So there's a few things going on here. Func is a function with a single parameter of undetermined type that returns an undefined or undetermined type. The sequence needs to be a sequence of elements, again of undetermined type. Custom map is itself a generator that yields results one by one. So custom map in this case is really an iterator. I mean, it is a generator, but it is also an iterator. And then each result yielded by custom map is a string. So there's a kind of a lot of things that we can start adding to this in terms of type hinting. Let's go ahead and add the fact that sequence can just be a sequence of anything. So we're going to say it's a sequence of any type. And you can see where any can come in useful here. Again, we probably won't have to specify it, because if we don't specify it, that's essentially what this means, right? If we just say it's a sequence, we're saying, hey, it's a sequence of whatever. But if you want to be explicit, you can do that. And we'll see examples where any does become required. In this case, it isn't. So that's the first thing we could do. Then we really want to document, to hint, right? What is func? What should func be? Well, we know that func should be a function that has a single argument, a single parameter. We're not going to specify what that parameter type is or what func should return. In this case, I'm going to let it be anything, because I don't care. It can be anything. As long as func can handle the type that you pass, hey, that's up to you. I just want to annotate that this function is a function of one argument. So for that, we're going to have to use another generic from the typing module. So from typing, we're going to import the callable callables in Python are kind of the generic term for anything that can be called. Could be functions, methods, things like that. So now that we have this callable, we can actually specify what its variables are going to be, what its parameters are going to be, and what its return type is going to be. So in this case, I want to specify the arguments, or hints for the arguments and hints for the return type. So we have two things we have to specify here. So it's going to be separated by a comma. To the left of the comma, we're going to specify what are the parameter type hints for this callable. And to the right of the comma, we're going to specify what's the return type hint. So the return type hint here is what? Well, it's any. We don't care, right? And so this is where any actually does come in useful. We can't really do away with it. And then the same thing here, we're going to specify the inputs essentially to this callable. So we do that by specifying another list essentially. What are we going to put in there? We're going to put a hint for every parameter of this function. Well, this function should only take one parameter. And again, we don't care what the type is. So it's going to be any, like so. So we can use this type hint as the type hint for this function over here. So let's go ahead and take that function again, copy paste. This time I'm going to put it over multiple lines. And I'm going to take this that I just created and we'll type hint it this way. Okay, so now we've kind of documented what func is. If somebody looks at this, they're going to say, oh, it just needs to be a function of one argument. It can take anything in and return anything. Okay, they kind of understand, right, what function should look like. Now the final thing that we want to type hint and annotate here is the fact that custom map is yielding. It's not going to return a list, for example. It's just going to yield elements one at a time. So essentially, this is an iterator. Yes, more specifically, it's a generator, but in this case, it's only doing a yield. So it's really only the iterator portion. And so we can go ahead and import this generic called iterator from typing. And so we can do, let's say, iterator. And again, we can specify the type. Let's say I'll do a string, right? That would be specifying that this is an iterator of strings. So now we can fully annotate our function. And I'm going to take this, copy back. And so what is this going to return? Well, it's going to return an iterator of strings. And this is why I put the string in there just to, so we wouldn't have any there as well. Specifically, we know that it's going to be a string, so we can give it a more specific type. Now note that for generators, more can be happening than just yielding a result, right? Generators can receive inputs as well as return something when they terminate. So that can also be annotated, but for that, you would have to use the generator generic, and you can read up more about it in the documentation. There's a link to it in the Jupyter Notebook in the GitHub repo. Let's do another callable annotation with a little bit more detail, just so we can see another example. So let's go ahead and say def apply. So we're going to take a function and then some values. And then this function here, apply, is going to iterate through every value, but it's expecting every value to be essentially two values, to be an iterable of two values that I'm going to unpack. So I'm going to say for value 1, comma value 2 in values, right? So basically I'm expecting values to be like a list of 2-element tuples, for example, or a list of 2-element lists, or any iterable of 2-element iterables. And then all it's going to do here, it's going to yield, and it's going to take the function and it's going to apply it to value 1 and value 2, like so. So that's all this function does. So we expect func to be a function of 2 arguments. And let's say that we're going to assume for our sake here that the apply function we're writing will, really needs to have either floats or ints. I know in this case it doesn't, but let's say that it does. Let's say that this func is going to be something that needs to be able to deal with ints or floats only. And then we also expect that values will be an iterable, not necessarily a sequence type, just an iterable of iterables containing 2 values. So how are we going to annotate this? Well, let's just look at a quick example of how you might call this function. Let's just make sure that we understand what it's doing. So I'm going to use a lambda for the function. So x comma y, that's going to return x plus y. And so I'm going to be able to deal with ints or floats with this function here. And then I'm going to do a list of, let's say 1 comma 1, and then maybe 2 comma 2, and then maybe I'll take a list, let's say 4 comma 5, like so. And so when I run this, you'll see that it did 1 plus 1 is 2, 2 plus 3 is 5, 4 plus 5 is 9. And so it was this list of either tuples or lists, so basically an iterable of iterables, but the iterables here have to be length 2. This was the function. We'll take in 2 values that are getting unpacked, right? And then just return the sum. So we're going to need to import one more generic. So from typing, import iterable. And let's go ahead and annotate this. So let's copy paste. And again, I'm going to put this over multiple lines. So what should func be? Well, func needs to be a callable. We've already imported callable, so we can use it. And it's going to be a callable of what? Well, it needs to take in 2 parameters, right? So it needs to take in 2 arguments. So if we look, right, this is kind of our base pattern for doing a callable. What should the first argument be? Well, it should be an int or a float. What should the second argument be? Should be an int or a float. I will take either an int or a float for either of the 2 and only 2 arguments. And it's going to return either an int or a float because this is what we expect this function to, what its behavior should be. And this is exactly what this behavior is for this lambda. It takes in either an int or a float, and it's going to return either an int or a float. So that's for the callable. What about the values? Well, the values should be an iterable of what? Of iterables. Of what? Well, int or float, right? So this is an iterable of iterables that contains int or floats. You can see it's actually quite a nice way of defining this, right? You saw how it's kind of difficult to explain it in words, right? It's an iterable of iterables with 2 elements. This is actually quite clear and concise as to what this type is. Okay, and then what is this going to be the return? What return type? Well, the return type is going to be, again, an iterator, just like we had before. We're doing this yield, right? And it's going to be an iterator of either, that's going to yield either ints or floats, like so. So going back to how things are evolving, and I mentioned that earlier at the beginning of the video, but type hinting is still evolving, and we've been using generics such as iterable and iterator that we've imported from the typing module. But these have been deprecated in the typing module because they're being moved to other locations, right? These other locations that already contain these generics, these abstract base classes already existed. They just didn't support the type hinting like we had over here, right? Like iterable, int, float, or that. It didn't support that. They do now. Starting in Python 3.9 and above, they do. So from collections.abstract base class, you can import, let's say, iterable and iterator. And so you can use those instead of the one from the typing. So if we go to that documentation, and the link is in the notebook. So let's make that a little bit bigger so we can see. But you can see that abstract base classes now contains things like collection, iterable, container. There's a bunch of those. So this is now documentation, right, for these abstract base classes that are in the typing module. We're looking at the typing module over here. And then we can see where they've been moving. So you can see we have corresponding collections and collections.abc. So things like, for example, a mapping, mutable sequence is in here as well. You can see it's been deprecated since version 3.9. Then we have corresponding to other types in collections.abc. We have the iterable, the iterator, the generator. Those are all there, and so on. Hashable, sized, etc. Okay, so let's go back to the code. But if you're working right now with Python 3.8 or you need to be compatible with those, just keep using the typing module to import those things. Just know that they are deprecated. So at some point in the future, you will not be able to import iterable and iterator from typing anymore. Now, one final thing I want to mention before signing off is that type hints can be used to annotate any variable, not just the function arguments, right? I've been showing you all these examples with function arguments, but you're not limited to that. In fact, if you've worked with data classes, you already know that. You know that you can specify that in a class. You could say class test, for example, and we're going to specify class variables. We'll say A is an integer with value 10. Or we could say B is a string with value ABC. Or even we could say L. Let's say L is a list of int or float, and that contains, let's say, 1 and 3.14. So this is a little less useful in this context, pure context, because a int equals 10. I know that a is an integer. I can see it right from the literal. But as we'll see in a future video that I'm going to do on the Pydantic third-party library, it's actually very useful to be able to do something like that. So we'll take a look at that in some detail. And then, of course, data classes take the same approach, where you use this type hinting to create, to declare your data class, to declare what your class looks like, and then the data class generates the class code by using the type hints. All right, thank you for watching.